welcome you to today's webinar. Thank you, dear. So we have today with us our esteemed guest, Dr. Chong, and he'll be taking us through the topic of the role of carbon neutral fuels in accelerating the energy transition. So Dr. Chong, if you could kindly introduce yourself to the guest, to the audience, so that we can just get started.
Yeah, sure. Thank you very much, Natasha. First of all, it's my pleasure to be invited to this webinar. I'm Dr. Chong from Shanghai Jiao Tong University, but I'm a Malaysian. I moved to China in 2018 and joined Shanghai Jiao Tong University as an academic here. So my background is related to energy. Specifically, I'm involved in the research of carbon neutral fuel and also energy system. I have been teaching courses related to this area, and I've taught DIA before in one of my classes, carbon neutral, net zero carbon fuels. So it is my pleasure again to introduce to you some of the progresses and also the advancements of net zero carbon fuel in recent years. Okay, I see that there are not many people online today. Maybe we can have a more intimate discussion as we go along. I've met Natasha, Dia, and I have IK. I wonder if IK is convenient to turn on your camera to say hi. And also Ken, right? Did I pronounce your name correctly, Ken?
Not actually, it's John.
Is Khan?
John, like.
John, okay.
Yes, correct.
All right, John.
Hello,
Great.
Doctor.
Where are you from, John? Yeah. Okay, IK, I see that you're online. Hi. So IK, where are you from? Or where are you now?
I'm from Nigeria,
I see.
but I'm
Okay.
currently in Germany.
Currently in
studying.
Germany.
Yeah.
Okay, so it's also a good morning to you there, right?
Yes, exactly. Good morning.
Okay, I've dropped a jar. Okay, but that's okay. Let's proceed with the webinar. So I'm going to share the screen right now. So just right. Can you see my screen?
Yes, it's visible.
Okay, very good. So let's get started. It is my pleasure to be here to share with you the topic of the role of carbon neutral fuels in accelerating energy transition. So a little bit about myself. Just now I've mentioned that I come from Malaysia. I'm also I'm working in Shanghai Jiao Tong University in China. It's one of the top university in China. So I'm heading the Clean Energy and Combustion Laboratory at the China-UK Low Carbon College. So our Low Carbon College is one of the colleges in Shanghai Jiao Tong University. We were established in 2017, and we are 6 years old now. So in this college, we have two programs. One is the low carbon power and also low carbon environment. So we also have another new program coming up is the energy storage and hydrogen energy. So as you can see, we are focusing a lot on the low carbon technology. Okay, so these are master courses. If you are interested, feel free to check out our website. So here is a bit about my background. I have done a lot of research related to fuel. I have gotten some awards before. My research interest is specifically on the low carbon transport, fuel, clean energy system, combustion, and sustainability. So this is the institution where I'm based at right now, Shanghai Jiao Tong University. This university is one of the oldest university in China, founded in 1896. If we go by ranking, we are, ranked number 3 or number 4, or some say number 5 in China. Traditionally, Shanghai Jiao Tong University is quite strong in engineering, especially in the discipline of power and energy engineering. Okay, environmental science, finance related to low carbon technology. And this is my college. It is called China UK Low Carbon College because we are jointly founded. We are founded jointly by Shanghai Jiao University and University of Edinburgh. That is why it is called China UK. So we were established in 2017, located at Lingang Special Free Trade Zone in Shanghai. We are away from the main campus, about 50 kilometers away from Lingang. And it is quite exciting because our college is situated at a free trade zone area, which is specifically gazetted for the rapid development. Okay, so it is a very modern, international, low carbon city. We are very accessible to the airport, just 35 minutes from the Pudong International Airport. So if you ever come to China or Shanghai, welcome to drop by. Just a little bit of background about the city that I'm living in right now. It is called Lingang. If you fly to Shanghai, when you're about to reach Shanghai, look out the window of the aircraft, you will see a very round-shaped lake, which is known as the Dishui Lake. It is even more beautiful at night. Okay, so that is a sign to say that you are near Shanghai. And this is a man-made lake, and the city is built around this lake. Okay, since 2019, this area has been gazetted as the free trade zone. It has a mission to establish a high-end manufacturing hub, finance hub, as well as a low-carbon city hub. Okay, and we are located at the southern tip of Shanghai. If you look at the map on the right-hand side, this is Lingang, the tip of the Shanghai. And interestingly, this Shanghai has their own autonomy in terms of some policy, such as the policy that welcomes talents, entrepreneurs from outside China. Okay, so I'm one of the beneficiary of this system. If you're interested to come and live and also work in Shanghai, you can also check out Lingang, this area. So why is this area so special? Okay, throughout the whole China, this is one of the area that has received a lot of attention. Okay, mainly because of their aggressiveness in promoting high-end manufacturing, attracting talents, and also a lot of other things. So among some of the well-known tenants over here in Lingang is this Tesla Gigafactory. So they attracted Tesla to come and build their Gigafactory at Lingang. In 2019, this Gigafactory was officially started their construction very, very quickly. It was finished within 2 years. In 2021, this Gigafactory produced almost 50% of the global Tesla production. So their speed was marvelous. Okay, it's very, very impressive. Needless to say, Tesla is just one of the many manufacturing companies, high-end companies that have based their manufacturing hub here. There are many other more that are related to low carbon energy. So in terms of the city development, they focus a lot on sustainability. In terms of transport, they want it to be green. So they emphasize a lot on low carbon transport system. So all the buses, public buses in this Lingang are pure electric. Okay, so there is no emission from the buses because all are purely electrified. And they have put a lot of public rental bicycles, bike sharing scheme for people to move around. Okay, and they also introduce a intelligent transportation system. They also built the automatic driving city, where this autonomous car, okay, this company can test their car in this area. So in the future, they are going to put more of this kind of so-called smart vehicles on the road in Lingang. And this is one of the sustainable transport introduced in Lingang, the world's first digital rail guided tram at Lingang. Officially test run in 2021. Right now, it is fully functional. Okay, so this is an electrified tram, but they are digitally rail guided. So this is also one of the green transport at Lingang. Apart from that, sorry, don't be surprised that you will see some fuel cell vehicle buses at Lingang. Okay, right now they have 2 routes, mainly for demonstration purposes, but these 2 routes operate using the hydrogen fuel cell buses. Until now, 2 years of running, fully functional. It works exactly like, it feels exactly like the EV buses, and it is very, very clean. So this shows that sustainable transport can actually happen if we have a proper plan and also technology in place. Okay, in Shanghai, 2022, in June last year, Shanghai government has introduced a hydrogen industry medium and long-term development plan, which covers 2022 until 2035. Now, under this plan, it is specifically mentioned that by 2025, they will build 70 hydrogen refueling stations all around Shanghai. There will be 10,000 fuel cell vehicles operating on the road. And the whole hydrogen industry supply chain in Shanghai will exceed 100 billion yuan. This is their ambition in pushing for a green, for the hydrogen sector in Shanghai. Now, apart from the transportation system at Lingang, we also can see a lot of offshore wind farm just off the coast of Lingang, okay, which has a capacity of 100 megawatt electricity, generating 260 million kilowatts of electricity per year, which can meet the annual electricity demand of more than 200,000 households in Shanghai. So if you see, there is a bridge here from Lingang that connects to the port, okay, Yanshangang. This is the deep sea port. Now, along this bridge, when you look out, you will see this wind farm. It is huge, okay, and this was built a couple of years before. It is very, very successful, and this shows that offshore wind farm is going to be a big trend in China as well. Okay, we estimate that 24,000 metric tons of CO2 can be reduced just because of this wind farm. So that is a background introduction about the town where I live in. Okay, when I live there, it is quite amazing to see all this new energy, new technology coming about. And we can feel the energy transition happening very, very aggressively and rapidly in China. Okay, because China has this ambition to move towards a carbon neutrality society by 2060. And Shanghai, as a metropolitan city, they are quite aggressive in this. So here, I'm going to move on to the global energy transition to have a hawk-eye view on the global perspective of how the energy is shifting in the future. So back to the very basic. Why are we focusing on energy transition? I'm sure you have seen this graph before. So that is the trend of temperature rise, or the global temperature rise. You can see that over the past few decades, the global temperature has risen very steadily, okay, up until now. And we are at a very, very dangerous level because we are going to exceed the 1.5 degrees Celsius limit. Okay. Now, if we don't do anything about the rise of temperature, the global temperature is going to continue to rise, exceed 1.5 degrees Celsius until 2 degrees Celsius. And if it reaches beyond 2 degrees Celsius, the Earth will have no turning back, because the global temperature rise will lead to a lot of extreme events, climate change, that will happen very, very rapidly in the future. Take, for example, now, Dia came to China. He experiences the hot weather in China. Now, if you ask any Chinese, 10 years ago, a decade or 2 decades ago, it wasn't like this. It was much more better in terms of the temperature. Yeah, much more cooling than now. So this is one example of a climate change. Okay, in Europe example, okay, maybe during the summer, the weather has become more and more extreme as compared to a few decades ago. So that is also one of the consequences of that. In certain area, we have flooding. Okay, just last month in Beijing, there was a huge flood in Hebei province and also Beijing. Okay, so that is also maybe related to the climate change event. Right, so we need to do something about this, control the rise of the temperature. So one of the big effort, okay, agreed by all countries around the world is through the Paris Agreement, where all countries agree to try to limit the rise of temperature to within 1.5 degrees Celsius. That is the limit. We try to do that. Okay, so we don't have a lot of time. All countries must start acting now, right? Extreme weather event that is highly related to the climate change. In German, if you can still remember, okay, in 2021, there was a huge flood. Okay, that happens in like once in 100 years, right? We can't expect that. In Henan, in China, for example, 2021 as well, July, a sudden 1 in 100 years kind of event causes a massive flood, flooding the whole area. Okay, which has a huge impact to tens of 20 millions of people with that. So all these are related to climate change. And because of the imbalances of the temperature, okay, there will be a lot of social and economic impact because of climate change. Okay, apart from the extreme weather, people living along the coast that will face the rise of sea level, which will engulf their land. Loss of capacity to work due to the extreme heat. Yeah, I'm deeply affected by that. Okay, because of the temperature, sometimes I just feel like so lethargic. More wars because they want to have access to limited resources, relocation of the town, shrinking productivity of agricultural harvest, the price of the commodity or goods rises, okay, extreme meteorological phenomena, etc. So all these can be traced back and related to climate change. Now, what causes the global temperature rise? Greenhouse gases, everybody knows. Where does all these greenhouse gases coming from? If you look at this graph, this chart, about 73% of the GHG come from the energy sector. Among this, transportation contributes about 12%, residential 11%, petrochemical industry 4%, iron and steel industry 7.2%. All these consume a lot of energy. The industry 5%, waste 5%, agricultural sector 18.4%. Needless to say, the energy sector is the big contributor. Okay, so we are interested in energy. There's a lot of room for us to tackle this, to reduce the emissions of greenhouse gases. So energy is our focus here. So all countries have committed and come together, binded through the Paris Agreement to battle climate change. China, in 2020, September, President Xi Jinping announced that they will commit to carbon neutrality target. Okay, so China aims to achieve carbon neutrality by 2060, and we aim to reach the peak before 2030. There isn't much time left, okay, less than 40 years, but China is committed to do so. A lot of other countries, especially such as the US or the Europe or in the West, they have set 2050 as the target. Okay, so we hope that by putting a lot of effort in this, we can reverse the trend. We can control the emissions of GHG. We can limit the rise of the global temperature. So as mentioned, China has set 2060 as the target. Sweden is a bit earlier, 2045. The US 2050 is the target. Okay, a lot of countries. Uruguay has set an earlier target of 2030. and etc. Even India, okay, India has set 2070 as the carbon neutral target. So almost all countries around the world have a carbon neutrality target. Now, if we look at globally, okay, globally, about 40 billion tons of CO2 is being emitted every year. China occupied or contributed about a quarter of these total emissions, okay, about 10 billion tons. The US, 5.3 billion tons, okay, the Europe, 28 countries add up together, 3.4 billion tons. India, because they are a growing economy, 2.7 billion tons. Now, if you look at US, they have already reached a peak by the mid of 2000. Okay, their emissions are going in a downward trend. Similarly, the Europe, they have reached their carbon neutrality, carbon peak by 1990s, in the early 90s. And they have remained stagnant. And recent decades, they are going down, right? So they have a head start in carbon neutrality. Okay, so their burden can be said to be lesser compared to China or India and other developing countries. Now, on the right-hand side, okay, China right now is about 29% in terms of CO2 emissions. Okay, India 7%. If you look at Russia, 5%. United States is second, 16%. So this is the global, the current status quo of the global CO2 emissions. Right. One thing that I would like to emphasize is that although China is the largest emitting country in terms of CO2, but per capita wise, it is not the highest. Okay, US would be the highest in terms of CO2 emissions per capita, right? So it would be a bit more fair to compare per capita wise. And from the personal level, there is much to think about how to reduce the CO2 from the personal level, okay, in terms of the way that we live or the habits, the lifestyle, the way we make we commute and etc. Right now in China, this is the installed capacity for the power generation. Okay, 52% is fossil fuel. Hydro occupies 60%, solar 60%, wind 14%, nuclear 2%. So clean energy or renewable energy occupies almost 50%. That is quite a good sign because China aims to replace the fossil fuel in the future. Okay, by 2060, China aims to have 80% of the power generated from clean and renewable energy. And we are moving towards that direction. Now, on the right-hand side here, okay, that is the total electricity generated. Now, you can see that there is a mismatch between the graph on the right and the left-hand side. The total electricity generated is still fossil-based, which is 66%. Hydro 50%, wind 9%, solar 5%. Now, this is quite strange because the installed capacity is about 32%, is about 30% for solar and wind. But the total electricity generated is less than 15%. Why is that? Why is that? Dia, do you have any idea? Why is this happening? For IK, yes.
And because of the fluctuating supply.
There you go. Yeah, because of the unstable, the fluctuating supply, or the intermittency of the renewable energy. Okay, they are not perfect. There is still a lot of disadvantages if we if we adopt renewable energy like solar and wind, and we are going to talk about that later. Okay, so this is the reality. The total electricity generated is still largely dependent on the fossil fuel, and we hope to expand this sector for the renewable sources. So that's why we are pushing for the development of renewable energies, such as solar, wind, nuclear, hydro. Why? Partly because we want to phase out the coal, we want to reduce the CO2, And also partly because we want to stimulate the economy. We want to have a greater impact positively on the social economy. We want to create more jobs. We want to increase our GDP. Okay, so all these are related to the energy transition. So you can say that pushing for the development of renewable energy will have positive impact not only to the environment, to the energy sector, to energy security, but also to social and environment. So that is the driver for this. Now, in terms of the technology, you can see that the net zero sources, such as there are quite a lot of them: wind, solar, wave, bioenergy, nuclear, okay, fossil fuel with CCUS, hydrogen-based fuel. All these are the potential energy that we can adopt. Right now, we all know that low carbon technology is a hit. Everybody is trying to look for the holy grail to have a clean source of energy. Okay, on the left-hand side, a lot of R&D is going on. Now, on the right-hand side, this is what we call the negative emissions technology. Direct air capture. If we can just capture the CO2 from the air, we have a negative emissions. If I can adopt bioenergy plus CCUS, I can have negative emissions, which is great. Energy storage technology. Okay, pushing for EV, pushing for hydrogen fuel cell vehicle, all this will hopefully lead to negative emissions technology. Okay, in China, this is the map of China. In fact, the color tone here shows the solar irradiation in different parts of China. The redder it is, the better the solar sources is. So on the west side of China, this has great potential for solar. Okay, in the north as well, Inner Mongolia, Shanghai, all these provinces have great potential for wind as well as solar energy. On the coastal area on the east side, okay, Shanghai is here, Nanjing, all these big cities are located on the coastal area. You can see that their solar is not that great, but the offshore wind is a great resources. Okay, so the development of renewable energy needs to be geographically dependent. So there's one problem here that China faces. All the solar and wind are concentrated in areas where there are less city and less people live in. How do we transmit all this renewable energy to the city on the east side where all this demand is high? So that is one of the big question, big problem to solve. Okay, high voltage transmission grid. That is one of the technology that we can adopt here. So the electricity generated here, which are green, you can use the high voltage transmission grid, transfer all this through a long distance to the city that you like. These are the technology from the grid level that needs to be developed. All right. So how do we use the solar energy? Okay, you can use that either through the solar thermal way, okay, such as the solar panel to absorb the heat so that we can have hot shower at home. Or you can convert the solar through the photovoltaic cell into electricity. So basically two ways. So on the right-hand side, we will use the solar water, okay, to convert the solar into electricity. And the benefit of doing so is that you can combine this energy system to the grid, okay, or you can even sell the power to the electric grid. Now, here is another way to fully utilize the solar energy, which is through the solar thermal way. Not sure if you have seen this solar power tower before. Okay, there is a tower right at the center. Surrounding it are thousands of mirrors. Okay, we call them heliostat. So all these mirrors are going to focus the sunlight to the tower. Okay, so all this sunlight will be directed and hit this tower. So this tower is going to absorb all the heat from the solar, okay, and this heat is going to be recycled, going to be circulated and pumped through a steam generator to generate steam. And the steam will be used to power the electric turbine and generate electricity. And the medium that we use to circulate this heat is called the molten salt. This kind of material has large heat capacity. They are cheap, and they have very good heat conductivity. So I circulate this molten salt, okay, in the pipeline. The cold molten salt is going to absorb the heat from the solar tower, and this heat will be carried to the steam generator to generate steam, and the cycle continues. Now, this is one of a very good way to utilize the solar power. However, this technology has its own disadvantage. It has to be built in a no man's land. It is not suitable to be built in city where the cost of the land is high. Okay, so in desert, such as the west side of China, where in the no man's land, you can use this technology. Now, this is the technology that was completed in 2019, and it is fully up and running in high sea, China, Shanghai. So this company called Luneng, they have built this 50 megawatt molten salt concentrated solar power project. Beautiful. Okay, and you can see that the land size it uses is massive. But in the no man's land area, it is feasible. All right. I hope to visit this kind of plant someday also. A bit of specs here about this Luneng High Sea CSP project. It was completed in 2019 in Shanghai area. The capacity is 50 megawatts. It has the storage of 12-hour annual electricity generation, 160 gigawatts. Okay, the number of heliostat, 4,400 mirrors over there. So a bit about the onshore wind. Okay, just now we talked about the solar. How do we use the solar power? And here's a bit of the wind. The wind sector is also growing very strongly. You can see that globally, we expect the wind farm is going to grow very rapidly until 2050. Okay, so the cumulative installed capacity is going to reach 4,400 gigawatt by 2050. We're going to generate lots of jobs along the way. Plus, the investment in this area is going to be a lot in the future because it is green. It is green energy. So apart from generating green electricity, we are going to develop this energy sector as well. Value creation. So if you look at, okay, under the carbon neutrality era, the opportunities that it brings in terms of job creation, okay, this graph is for China. 40 million new jobs will be created in the energy sector under this carbon neutrality vision, which is very important. Now, the first one here is the jobs related to renewable electricity generation. You can see that about 30 million jobs is going to be generated in the future. Power networks, 5 million. EV charging infrastructure, which is a big boom in China, 10 million jobs, and others you can see. Okay, so in the future, there will be more and more jobs opportunity related to green energy. So I'm going to talk a little bit about the energy system because we want to use solar, wind, and all these green electricities. We have to develop the smart renewable energy system. One of the problems that it brings when we use the solar and wind is the fluctuation. Okay, if you have high level of grid connected solar and wind, to the power grid company, it is very dangerous because who knows, maybe in a rainy day you don't have enough power to supply. So the fluctuation is something that we need to tackle. One way to tackle the fluctuation brought by renewable energy is through this energy storage system. So in the future, the smart energy system that we are looking at is going to be a combination of renewable energy plus the energy storage system to guarantee the energy security and stability of the power grid. So why solar and wind is not a perfect energy? Okay, if you look at the graph on the right-hand side, the red color line is the wind power output. You can see that it fluctuates, sometimes strong, sometimes not strong. Okay, at night, when the power demand is low, the wind is strong. Okay, you might have a lot of waste because you are not fully utilizing the energy. So how do I do that? How do I fully utilize the energy? If I have a battery set up to store this excess energy and use that during the day, that would be perfect, right? That will increase my my efficiency. Now, similarly, solar during daytime, the power output can be peaked, but at night, evening, or during midnight, there is no power. Okay, so that is not good. But if I have the energy storage system, I can ensure my supply of electricity during night. So that is the importance of the energy storage system. So in the future, when we have different renewable energy sources, such as the solar, wind, biomass, hydropower, okay, we need the energy distribution and storage system, okay, consisting of the battery, okay, or different kind of energy storage, pump hydro storage, or you can have the cold and thermal storage system network. And on the right-hand side here is the end users, because we want to accommodate the growing numbers of electric vehicles, the gargantuan appetite of energy from the industry, business, household, residents. Okay, so this energy system needs to be smart. It has a smart energy management system digitally to distribute this energy in a smart way. Okay, that is why a smart energy management system is one of the focus research area in the energy community. Okay, we have to optimize the various energy subsystem so that all these different modules, they can work together as a whole. Now, in terms of energy storage, there are many options. You can have batteries, but the problem with batteries is that the energy storage capacity is not that huge, and however, the release time is fast. The response time is fast. That is a great thing. Limited by the size, you can look for other options such as the pump hydro. Okay, the response time is slower, but the amount of energy that it can store is much more compared to the battery. So that is something that we can consider. Okay, other energy storage method, such as if you can convert the green electricity into hydrogen or methane, we can store them for a long period of time and in a big scale. Okay, so that is suitable for long-term storage. Now, in the future, if the green electricity is cheap enough, the new energy system is going to move towards the hydrogen economy. Okay, we are going to use the green electricity to produce hydrogen or methane or synthetic methane in the future. This fuel, okay, can be stored or used in the transportation sector, which is very, very flexible. The hydrogen combined with the carbon sources captured from the flue gas of the industry. Through certain processes, we can make different kinds of fuel, such as synthetic methane or liquid fuel, liquid hydrocarbon fuel, and etc. Okay, there are other emerging technologies such as the superconducting coil capacitor, which has a fast response time. Okay, but their capacity is not high, but still we can use them in certain area. Okay, so this is the energy storage sector that has gained wide attention and is a very important research area in the future. Now, Tesla is going to build their second gigafactory in Lingang, but this time they are not going to build cars. In fact, they are going to build this energy storage battery. Okay, mega pack. They aim to build 10,000 unit, okay, nearly 40 gigawatts. They signed the deal this year, April. They're going to start the construction of the plant in the third quarter of 2023. And by next year, second quarter, they're going to start producing this mega pack energy storage. So this is how we envisage the future renewable energy system going to be. It is going to be more flat. It is going to be more distributed form. Okay, for example, this area is going to utilize the local resources, either solar or wind. Okay, abundantly available. This subsystem is going to produce the electricity for that area, for this area. Now, if this area has insufficient electricity, area number 2 can supply the electricity to area number 1, because all this area is going to be internet connected through the energy network, controlled by the global energy management system. This is the future smart renewable energy system that we envisage is going to be. Now, apart from the electricity grid, we might also have the gas grid or the heat grid connected together. So it is multi-energy, okay, multi-energy plus the electricity, and also they are very, very intimately connected in a smart energy distribution system. Now, here is one energy system that I would like to introduce you. I will have the solar power station generating green electricity. Now, in the future, I might use this electricity to produce hydrogen through the electrolyzer here. I might still use coal-fired power plant to generate electricity. Part of them is supplied to the grid. Part of them is used to generate hydrogen, okay, supplied to here to produce hydrogen. But the CO2 produced in the flue gas, I'm going to capture that. I'm going to capture the CO2 and use this carbon source combined with the hydrogen here through certain processes here to produce synthetic methane, or I can produce synthetic methanol. This fuel, I can store them for a long time, or I can use them in the transportation sector. If needed, I can quickly convert these methane gases by burning them in a gas turbine to generate electricity and supply to the grid. So this is a system that is clean, produces no CO2, and very versatile. So in the future, we are going to see a lot of this kind of different configuration of new energy system in the future to utilize the renewable sources. Needless to say, a lot of work needs to be done. And right now, the energy sector community is trying to devise the optimal system like this. Okay, so there are a lot of opportunities and also research opportunity in this area. So very quickly, I'm going to go into the transportation sector. Just now, I've talked about from the power generation level, okay, or the renewable energy system level. But right now, let's go very quickly into the transportation sector. So electric vehicle is a big boom in China. Products or brand names like BYD, okay, XPeng, maybe you have heard before, they have managed to ship out globally to many, many areas around the world. Tesla, for example, is a global phenomenon. Okay, in China, it is becoming more and more common because the public have already accepted electric vehicle. You can see a lot of charging station being built everywhere, so charging is not a problem. So we expect this is going to be a very important way to decarbonize for the transport sector. So other than EV, which we all are familiar with, the fuel cell vehicle is gaining momentum as well. Companies like Toyota or Honda, in fact, the Japanese have produced the fuel cell vehicle like a decade ago. The top one here is Mirai. This is the Mirai second generation model. Honda Clarity. The technology is already available, but due to the lack of hydrogen refilling station and also the high cost of this car, this cannot kick off. Okay, but battery vehicle can kick off very quickly. If you look at the car anatomy here, you have the fuel tank, which is to store the hydrogen, the fuel cell stack. Now, the hydrogen is going to be supplied here, and electricity is going to generate from the fuel cell stack. So basically, this is how it operates. But this is how a hydrogen station is going to look like. Okay, in China, they are going to build a lot of this. Okay, in Shanghai, I mentioned just now, 70 hydrogen filling stations is going to happen in by 2025. So for the hydrogen charging, okay, basically it takes only like 3 to 5 minutes to fully charge the tank. Now compared to the EV vehicles, which takes like at least half to 1 hour for fast charging, slow charging, it can take hours. This is a huge advantage. Okay, for a single charge, the car can run about 600 kilometers. Not bad. So why hydrogen? Okay, apart from using them in the fuel cell, the hydrogen fuel can be used in many areas. Okay, you can use them for the ammonia production, which is the crucial element for the fertilizer production. You can use in the metal production. You can burn them as fuel. Okay, you can use hydrogen as the petrochemical platform chemical, okay, to produce other products. So hydrogen is a very versatile fuel. In terms of energy capacity, okay, per mass wise, the energy density is very high, okay, 120 megajoule. So, but per volumetric wise, it is not that great. Okay, that is why it still cannot be used to replace the liquid fuel because of the energy density. It's not that high yet. So how does the hydrogen fuel cell work? Okay, hydrogen fuel cell works based on this principle. You supply the hydrogen gas here. Okay, at the anode, the hydrogen is going to react. Okay, the hydrogen ion is going to pass through this membrane, okay, polymer electrolyte membrane, crosses to the other side of the cathode, combined with the oxygen to produce water. Now, on the anode side, because of the reaction, the electron is going to flow through the outside circuit and through the load. This is how we generate the electricity. Now, the efficiency for the hydrogen fuel cell is higher compared to the conventional internal combustion engine. Okay, that is where its advantage is. It is not bounded by the Carnot cycle. Okay, so that is the big advantage for this hydrogen fuel cell. This is how the hydrogen fuel cell looks like. Okay, this is the picture taken by myself before the COVID-19. I visited Dongfang Electric. This is a 24 kilowatt hydrogen fuel cell stack. Now, if you stack more of this cell together, the power output is going to increase, just like our ordinary battery. You stack more of them, the power output is going to be higher. On the right-hand side, this company can produce the hydrogen fuel cell for the buses. They can mass produce. Now in Shanghai, okay, by 2025, 70 hydrogen refueling station is going to be built. Right now, there are many demonstration projects that operates, such as this truck operate using the hydrogen. Okay, burning hydrogen in internal combustion engine is matured. The technology is ready. On the right-hand side here, this is a picture taken by myself. The hydrogen-powered fuel cell bike sharing in Lingang. You see, this hydrogen technology is not far away from our daily life. So in the power generation sector, hydrogen can be burned in the gas turbine engine to generate power. Siemens, for example, have looked in the future. They are preparing for the future by adapting their gas turbine to accommodate hydrogen at different percentage. So certain models can burn 5% hydrogen, 25%, or some even can burn up to 100% hydrogen in the gas turbine. Okay, so in the future, hydrogen is going to be a very important fuel, and companies like Siemens are getting ready for that. So this is how a hydrogen flame looks like. Okay, I myself am involved in the hydrogen combustion technology. Okay, so what we do is we examine how the fuel burns. Okay, we check the emissions, we check the combustion stability, we check the combustion efficiency, and etc. So in domestic application, on the right-hand side here, the hydrogen boiler is already here. Okay, the world's first hydrogen-powered domestic boiler is ready. And who knows, in the future, we might be using hydrogen or hydrogen mixed with natural gas in our household, okay, to get hot water. Now, in the industry, okay, boiler like this is under conceptual design. When we burn hydrogen, we are going to produce water, right? Now, these are valuable steam. If I can collect all this steam, I can use them for further processes. So the efficiency can be much, much higher. So in essence, when I burn hydrogen, I don't produce any CO2 and I get steam out of it. So this kind of concept can also be applied in the industry. So we have talked about using renewable electricity to produce hydrogen using this electrolyzer. Okay, we call this power to hydrogen technology, power to X. The X here refers to the different kind of fuel that we want to produce. Okay, if we want to produce hydrogen, we call them power to hydrogen. Now, the limitation for this power to hydrogen is actually the electrolyzer. Right now, the cost of the electrolyzer is quite high. Okay, here I introduce two types of electrolyzer to you. One is called the alkaline electrolyzer. Okay, so for this to happen, you supply water and electricity. Now the electrolyzer, okay, is going to split the water molecule into hydrogen and oxygen. You can collect the oxygen for further uses. The hydrogen produced here, you have to separate the gas and the water. You got to deox it because you cannot have any trace of oxygen in the hydrogen. It's going to explode. You got to dry the gases, compress it before you store them in the tank. For the electrolyzer, you need the electrolyte. Okay, so you have a circuit here to circulate the electrolyte, sodium hydroxide electrolyte in the tank. Okay, we expect this to be feasible in a large-scale hydrogen production system because this alkaline electrolyzer is much more cost-effective compared to the PEM electrolyzer. Now, this is the PEM electrolyzer, polymer electrolyte membrane electrolyzer. You can see that the electrolyzer has no additional circuit because it only has a thin membrane here, 0.2 millimeter in thickness. Okay, where the hydrogen ion is going to cross the membrane to the other side to form the water. Now, this system is simpler, but the cost is higher. Okay, it's much more flexible. It can be used in car, in mobile application, but the cost is going to be higher if we scale it up for industry use. Because this kind of electrolyzer, they use the noble metal, platinum. Okay, the cost is high. You can think of this electrolyzer as the reverse of the hydrogen fuel cell. Because hydrogen fuel cell requires hydrogen and oxygen to produce electricity and water, right? But the electrolyzer is the reverse. You supply electricity, you supply water, the output you get is the hydrogen plus the oxygen, all right? So the technology is somewhat similar, but works in a different way. Now, in terms of the cost of hydrogen, you can see that natural gas reforming is the cheapest way to produce hydrogen. The cost is about $2 per kilogram. Using coal is quite cheap as well, okay, around $2 per kilogram of hydrogen. But renewable energy like wind, okay, and solar is still expensive at the moment. It costs about $4 to $8 per kilogram of hydrogen. But in the future, by 2050, we expect this cost is going to go down to $2, around $2, right, for solar and wind. By that time, it will be competitive. It will be widely accepted by the community, and it will be very, very competitive compared to the fossil fuel base. All right. So this is what we hope to achieve in the future. Right now, the cost of hydrogen is still high because of this reason. Okay, right now the cost is about $5 per kilogram of hydrogen produced. In the future, we hope to have $1. We hope to have per kilogram $1. Now, the way to do that is we have to reduce the cost of the electrolyzer. If we can reduce the cost of electrolyzer by 80%, you can drop the cost by about $2. If the renewable electricity, the green electricity cost is going to be lower, okay, we reduce the cost to 20 USD per megawatt, you can reduce the cost of hydrogen by $1. And if I can increase the efficiency of the electrolyzer by 10%, let's say, I'm going to have the reduced hydrogen cost by this much. So these three are the main factors that pushes the cost of hydrogen high. Okay, so a lot of R&D is needed to tackle these three costs. So we have talked a lot about the power to hydrogen, okay, using renewable energy to produce hydrogen up until here. We can use the hydrogen to combine with CO2, okay, through some chemical process to produce liquid fuel. This is what we call the power to liquid technology. Okay. Now, how do we do this magic? We need the feedstock, which is the syngas. The syngas is a composition of hydrogen and carbon monoxide. Hydrogen I can produce from the green electricity. The carbon monoxide, I can get that from the industry by using the carbon capture technology. By manipulating the ratio of hydrogen and CO and put them under different processes, okay, I can do the magic. I can produce different types of liquid fuel like diesel and kerosene or methanol or synthetic methane. Depends on the conditions, the chemical process that I use. Okay, so all this is what we hope to produce using the green electricity and also hydrogen in the future. We call this power to liquid technology. Now, how about the cost of hydrogen? Is it the same everywhere else? Which country has the most potential of producing cheap hydrogen? Here is a map to tell you that. Okay, this map is from the IEA report. You can see that the redder it is, the lower the cost of hydrogen is. Okay, in certain parts of China, it can be very, very cost competitive. In the Middle East, for example, in India, along the equatorial line where the sunlight is abundant, it is a good place to produce hydrogen. The cost is lower. In Australia, they are investing a lot in this as well. It can be quite competitive to produce hydrogen. But in Russia, my friend, or in Europe, you can see that the cost to produce hydrogen can be quite high. So it might not be a good option to produce green electricity, green hydrogen in this area in the future. Okay, so but worry not, because other technology, okay, such as the gasification of hydrogen, of biomass, okay, or steam reforming plus CCUS can also be adopted to produce hydrogen in different way. These are the CCUS project that is gaining momentum worldwide. Okay, you can see that in Europe there are quite a number of projects operating there. In the Australia, there are some pyrolysis project going on with CCUS, okay, in China as well. So there is much hope to produce hydrogen from fossil fuel with CCUS. Now, very quickly, apart from hydrogen, some other net zero carbon fuel include this kind of biofuel. Okay, so we are moving from first generation biofuel to second generation biofuel. Second generation is no feedstock that do not compete with food, okay, such as jatropha. We cannot eat this. They are poisonous. So we can use the seed to extract the oil and produce the biofuel. We can use algae, okay? We can use waste cooking oil, lignin, for example, to produce the second or third generation biofuel. Now, the first generation is there's always controversy around it. Okay, because the soil, rapeseed, palm oil, they are edible. Okay, they are competing with food. You might drive the price of the commodity up, right? So basically, they can classify through this, yeah, first, second, third generation, and fourth generation biofuel. Third generation is what we use the algae, okay, because they do not compete with food source and they do not use land for production. So algae has a lot of potential as well. Fourth generation is that if we modify genetically the algae or the non-food source, you suddenly have an increase of the oil, okay, the fatty acid. Now, this is what we call the fourth generation, yeah, genetically modified. Okay, right. So these are the different technology used to produce different kind of biofuel. Typically, biofuel exists in these three forms: biodiesel, bioethanol, biogas. Biodiesel is the substitute to diesel, which can be produced through the transesterification process using this kind of oil and fat, okay, or lipids. So this is biodiesel. Bioethanol is the substitute to gasoline, which can be produced through the fermentation process, hydrolysis process, using sugarcane, lignocellulosic material. Okay, Brazil has a lot of bioethanol. Biogas is that I can use the anaerobic digestion, okay, use some microbes, ferment it, and I can convert lignocellulosic material, manure into biogas. So that is the substitute to natural gas. Okay, right now, worldwide, bioethanol is mostly produced, followed by biodiesel. Other biodiesel like biogas or biojet fuel occupies a small amount. Okay, so this is the status quo. So we expect in the future, by 2040, 2050, biofuel is going to be important way as well. Okay, one of the important method to decarbonize. So in the US, you can find bioethanol is widely used. They produce the bioethanol from corn. Okay, the price is also different. E50 means that there are 15% bioethanol in the fuel. E30, 30%. E85, that means high level of bioethanol available, 85%. Okay, this is in China. In certain area, certain provinces, we have E10. Okay, 10% bioethanol in the fuel. So in the aviation sector, okay, they are aggressively decarbonizing as well. So the ICAO have stated that the way to decarbonize the aviation industry is through the use of biojet fuel. If you look at the green area here, these are biofuel. The blue line here is the contribution by technology advancement. A better engine, better technology, better flying technique can reduce the carbon emission by this much. The red color here is the air traffic management and infrastructure. Okay, you fly in a better way, better flight envelope, right? Better airport infrastructure, you can reduce a little bit, not much. So the large contributor in terms of carbon reduction is still alternative fuel. Okay, the alternative fuel here means biojet fuel, not hydrogen, because hydrogen has no way to replace the kerosene in the aircraft because the energy density is too low. If I were to use liquid hydrogen, I need to liquefy it. Okay, I need to change the engine, which is too hassle. Okay, which is not feasible for large passenger aircraft. So the most feasible way is still to use the alternative fuel, biojet fuel, which is drop-in or can be blended with existing kerosene to be used in the engine. Okay, so I've talked about this. Now, right now, this standard is the recent standard to tell us the different pathway to produce different biojet fuel. Right now, there are 7 pathways approved to produce biojet fuel. You can see that fatty acid, hydroprocessed fatty acid. This is the alcohol to jet fuel using fermented sugar to produce biojet fuel. This is alcohol jet fuel as well. This is catalytic hydrothermolysis jet fuel. This is from algae. So different processing pathway to produce different types of biojet fuel. But you must understand, all the biojet fuel that you produce, they are similar because they have to comply to this standard specification of D7566. That means, although the feedstock or the processing pathway is different, the end product is similar because you have to comply to the standard of this. So right now, different pathway, different biojet fuel, you have a different blending limit with the conventional kerosene. Some are 10%, some are 50%. Okay, the most recent one, which is the algae biojet fuel, is only 10% limit. Now, this is the identified pathway for the production of biojet fuel. So basically, broadly speaking, I can have the lipid conversion pathway. So I can convert the oil or the lipids through the hydroprocessing pathway, and this is the HEFA pathway, A2. Or I can use the biochemical conversion pathway, where I can use some microbes, ferment the sugar, get the alcohol, and then oligomerize, hydroprocess them into jet fuel. This is what we call the alcohol to jet fuel pathway, okay, biochemical conversion. Or the thermal conversion pathway. You first gasify them, get the hydrogen and CO. Okay, from the syngas, you use the Fischer-Tropsch processing pathway to produce the Fischer-Tropsch synthetic paraffinic kerosene. Okay, so that is another pathway. So that is the broad 3 different ways that we can use to produce the biojet fuel. So right now in the Europe, Sky NRG is developing a lot of using a lot of HEFA technology. They are building a plant to produce this 10,000 tons of SAF. Okay, when you see the word SAF, that is the term that is used, yeah, sustainable aviation fuel. They call it SAF. KLM, this company, has been operating weekly using this biojet fuel. So they are leading company in using biojet fuel. In Japan, they use algae waste oil to produce the biojet fuel. Okay. So a lot of activities around the world. In Indonesia, they use the palm oil-based jet fuel. Okay, they have successfully tested that in a small aircraft. So in terms of carbon emissions potential, you can see that this is the baseline. Okay, if we burn conventional jet fuel, it's about 90 grams of CO2 per megajoule. Okay, that is the baseline. Now, all these are biojet fuel. You can see that we can achieve different degree of CO2 reduction, some up to 90%, some are 40%, using different kind of feedstock and also the production pathway. Now, the one that exceeds the baseline is coal, using coal to produce the fuel, using the Fischer-Tropsch pathway. Even with CCUS, you still exceed the baseline, which is not good. Okay, so that should not be used because that is not helping in terms of the CO2 reduction. Natural gas to Fischer-Tropsch fuel, you're going to have more CO2 production rather than a reduction. Okay, coal to Fischer-Tropsch fuel without CCUS, this is the worst. This is the worst. Right. So bottom line is biojet fuel has the potential to reduce CO2. In China, because of our dietary, we produce a lot of waste cooking oil. China has invested a lot in this waste cooking oil biojet fuel. They have tested flight. They also can produce in large scale. Okay, this happened in 2013. So over the past decade, a lot of companies, a lot of airline companies have tested flight. Okay, the earliest flight can be traced back to 2008, where Sir Richard Branson operated the first biofuel flight. So since then, a lot of companies have tried that. Okay, the most recent one is Etihad Airways, 2019. They conducted a trial flight using biojet fuel derived from Salicornia plant. So this plant is grown in the desert using seawater. Quite amazing. So very quickly, in the marine transport, okay, marine transport also talk about decarbonization. So by 2050, they hope to achieve 70% reduction of CO2. Okay. Now, why not 100%? Because in the shipping industry, it is almost too difficult to do so. Almost too difficult to replace the fuel. So they have set a modest target. The International Maritime Organization has set a 70% carbon intensity reduction. We hope to achieve that. So by 2030, we achieve a 40% carbon intensity reduction. Okay, by 2050, okay, 70% reduction. So how do we do that? Okay, right now we are using fossil fuel, right? In the process of using zero carbon fuel, we are going to use LNG as the transition fuel. Okay, liquefy natural gas. So as a transition, bridge technology, in the future, we hope to use zero carbon fuel like hydrogen or ammonia, okay, or electrification. So this is the pathway for future green ships. And this is the, okay, large crude carrier powered by LNG, which is happening right now. China has the capacity to build this crude carrier powered by LNG. And if we use LNG, it is much more cleaner compared to the heavy oil used by a lot of ships right now. Now, this is what is projected in the future. Okay, by 2050, we still cannot totally displace oil-based fuel. About 40% still use the heavy oil, okay, or fossil-based fuel. But we are going to have more variety. LNG, methanol, biofuel is going to be in place. Okay, 35% hydrogen and hydrogen, which is zero carbon fuel. In our lab, we do a lot of ammonia, hydrogen, methane combustion, and these are from our lab. Okay, the bottom line is we try to have the efficient burning with low NOx because nitrogen is present in the molecule. We try to avoid the production of NOx. Okay, although no CO2 is produced, but NOx is a problem. Okay, we try to avoid that. How do we do that? We devise some new burning technology like this kind of burning strategy. Pilot ammonia injection surrounded by lean methane flame. Okay, the reduction can be up to 30 to 40% in terms of NOx. So in conclusion, ladies and gentlemen, I've shared with you the different possibility or the diverse research opportunity in the area of zero carbon fuel. Okay, there is a strong driver to push towards the R&D of renewable energy. Okay, from the smart energy system, there is one big area that needs to be researched. Smart energy system will lead to the production of zero carbon fuel, okay, through the Power-to-X technology. And this kind of synthetic fuel, renewable fuel, can be used to decarbonize the transportation sector, either ground transport, marine transport, or the aviation transportation sector. So there's a lot of work needs to be done in the fuel sector, production and application. From the energy sector, the renewable sector, renewable energy system, and also the Power-to-X technology is something that we can consider. Right. So based on this, I would like to conclude the talk for today. Right. Sorry for exceeding the time. If we have some questions, feel free to ask right now.
Thank you so much, Dr. Chong, for this informative presentation. I've learned quite a lot, and I would like to invite the audience to write their questions in the chat box, or if they're comfortable, they can just go ahead and ask you directly.
Yeah.
Okay, I have a question.
Yes, I can.
Okay, thank you for the presentation. Yes, it was long, but quite interesting and informative as well. I appreciate that. And in one of the slides, you talked about carbon peak, where you said, I think the US has gotten to their carbon peak and they are beginning to, go down. So I was wondering, what does that mean? Does it mean that they do not generate more carbon?
Yeah, you can think of that way. That means that the total CO2 production is not as high as it used to be. The total CO2 generated is going in a downward trend. Okay, but at the same time, they can still maintain the economic growth. Okay, that means their economic growth is not dependent on the usage of fossil fuel. They are moving towards a high-end economy. But a lot of developing countries like or China or India, we still rely on fossil fuel to get the power. Okay, their economy strongly depends on the fossil fuel. That is the difference.
Okay, I think I get it now. Thank you very much.
No problem.
Okay, I have a question written down here and I'll ask it. Looking into the future, what do you envision as the most exciting possibilities for carbon neutral fuels? And how can collaborative efforts between various sectors accelerate the integration into the global energy landscape?
In my opinion, I think the synthetic renewable fuel is going to be very, very important. Okay, through the use of power to X technology, we are going to be able to produce different kinds of fuel. Okay, or we can call them the electro fuel. That will be very important in the transportation sector, because right now there's a lot of talk about disphasing, okay, renouncing the use of internal combustion engine. Okay, all these car manufacturers are hoping to reverse this trend. They are banking the development of e-fuel in the future to be used in the vehicle in the future. Okay, so I would think that the net zero carbon fuel has a great prospect in the future. There's a lot of opportunity available. A lot of R&D is still needed to efficiently produce this kind of fuel. Okay, and then how do we? It is not easy because this is a interdisciplinary subject. So you need the chemical background, you need the chemistry, mechanical background to do so. Okay, so it is very multidisciplinary, and you can look at it from the system level, chemistry level, application level. So there's a lot of room for research.
Okay, thank you for the answer. I understand. Okay, so I don't see any questions in the chat box, so I'm assuming everyone has grasped something useful for them. And without any further ado, thank you so much once again for all the effort that you've put into this presentation and the webinar. On behalf of the global energy community, we'd like to say thank you, and yeah, thank you for your time and your efforts.
It's my pleasure. Thank you very much, Natasha. Okay, thank you very much, guys.
Thank you, Dr. Chong.
Thank you. Have a great day and all the best in the future. Bye-bye.
Thank you very much. You too. Bye.
Thank you.
Bye.
Thanks.
Bye, Rob.
Bye-bye.
Thank you.